To make this interesting, I suppose, so you stay awake, is I'm going to make it a little personal today. And I'm going to start out with back in 2007, I sat in a WoodSolutions seminar in Perth run by Gregory Nolan. And it was all about how to build box beams. And we literally made a little box beam. Now at that time I was a practicing architect, working for an architectural firm, and I was incredibly frustrated that such a document like this didn't exist because I really wanted to learn more about wood, and yet there would be nothing in my architectural education that allowed me to have some confidence about that journey. But as a result of attending that WoodSolutions event, talking with Greg and others, I decided to have a shift in career. And my shift was to educate myself about what you could do with wood and where you might take it. So what you're actually going to see here today is the next iteration, in a way, of what you see of Gregory's just presented in his presentation. Partly because 2 jobs back, Greg was my boss. So let's move along in time a little bit. And I helped Greg with some of the early planning for this document. And so I learned a little bit about what the language was going to be. I certainly understood a bit more about the structures. And so I've been guiding my current role to a certain extent based on the thinking that went into this job. So my current role is with Wesbeam. Wesbeam make LVL in Western Australia. I'll talk a little bit more about that down the track. But within Wesbeam, I've been brought into the company to help 2 sides of the equation. The side from a manufacturer, about to understand about what the industry wants and needs, but also to help the industry itself better understand what manufacturers can bring to the equation. So I sit across both camps, if you like. All right, but before I really start, I'm going to talk a little about innovation first. It's a term that's been bandied around a lot today. It's on the title of our presentation. But I think it's worthwhile acknowledging that innovation itself needs to be defined in order for us to understand where mass timber and this emerging opportunity presents itself. So innovation is not invention. It's the practical implementation of invention. So that's a really important thing to grasp. When we talk about innovating with timber, we are actually trying to find some novel, original, effective uses for something that someone else or somewhere else has invented. So that's what innovation is. So I imagine in all our own ways, we're all innovators because we're all trying to find new ways to do with products that we're already familiar with. But innovation by itself isn't enough. It has to be able to break into an existing market. And that's where we have this new term, a term that's starting to emerge called EXNOVATION. So once we've innovated, if we stop there, no one's going to make any money of it. Nobody's going to benefit from it. So we have to go into EXNOVATION. That's where innovative products and systems, they go through a process of testing. Then they're determined to be best in class, assuming that that is successful. And then they enter the market through standardization. Standardization, I believe, is the goal that we all want to achieve. If we want to take some of the ideas that have been innovative and were invented and then become available, regularly available. I think with Christoph's presentation, I just come back from Europe with a WoodSolutions tour. I'm going to talk a little bit about it at the end. But some of the projects that he showed there, to me, is where innovation has transferred successfully to the market to EXNOVATION. That's where it becomes the everyday. Now, we saw some extreme examples of being able to do compound curved glue laminated beams, and they're doing it as an everyday thing, and they really are. I saw it with my own eyes on multiple projects. So if we think innovation, what are we innovating with things that we're already familiar with? And then the next step is, where can we go with that? What can we do to exnovate that into the everyday, into the regular application? That's the first part of what I'm going to talk about. The next thing is that this happens over time. It's not something that happens overnight. The path itself can be mapped. Now, I noticed early in one of the slides, I think it was Robert's slide, he had a, oh no, actually it wasn't Robert's slide. Anyway, there was an earlier slide that tried to map this out in quite a complex graph. I've got a much simpler version of it. You can see we have a simple graph there. On the upright is innovation, and then at the higher level, and then EXNOVATION at the lower level, and then it's time and market adoption. So if someone has an innovative idea, it tends to be a small idea. It tends to be a bit of a pilot idea. But over time, it will progress and slowly grow and become EXNOVATION, and the market adopts it. And then that cycle is repeated. The reason that I'm making this point is that I think it's really important. It doesn't matter where you sit within the spectrum of professions that are involved in construction, is that if you think about it in that context, you think what your role is, you will be part of the new language, the new opportunities that are presented. And I believe now, and I've set my career up, I think, to pursue this, that mass timber and engineered timber are going to be the next big thing. They already are in other countries, and I believe that is already the case now. It's developing now. Let's also look at the second part of my title. There was innovation, and then there was massive timber products. Yes, I am standing here today with a Wesbeam hat on, but previously I stood here in front of audiences just like this with a WoodSolutions hat. So I'm more than happy to talk about the range of innovative, massive timber products and how they fit into the matrix together, because I really do believe that there isn't one material that solves all the problems. Let's start with glulam. Glulam, or glue laminated timber, first became known, or was first documented to be used in 1842. Now that term, first extant use, is indicating that in 1842 someone glue laminated some beams and they put it up in a roof, and that building is still here today. It's a church in the UK. So in 1842 they started glue laminating beams together. First patent, 1872. First large span hall that I'm aware of, 1925 in Stockholm at Stockholm Central Station, still in place today. And the big glulam beams that are supporting the main hall there is spanning 32 metres. That's a combination of a milk-based glue and steel plates that wrap it around and support it. And that is still doing its job here and today. And to I guess, bring a local context to it, our largest free-spanning glue laminated structure here in Australia is the Sydney Olympic Dome, I believe. Gregory, Yep, 99 metres in Sydney. And if you ever get the chance to go to Homebush, and you go and poke around the building, go and have a look at that structure. It is just gorgeous. This dome-shaped, glue-laminated beam structure, and it's just spectacular. Right, the new boy on the block. No, not quite. LVL. LVL, which is laminated veneer lumber that Wesbeam manufacture in Perth. Now, that was developed to try and find an innovative way to use small section logs. So up until that point, they had been getting logs and sawing them up into studs and beams and elements like that. They realised that they could peel those logs and get a veneer off it and stick those together. In the 1980s, it was brought into the North American market as part of this EXNOVATION process. The first Australian factory came into South Australia in the 1990s. In 2004, Wesbeam set up in Western Australia specifically to make LVL to replace as a replacement for the F-17 hardwood industry in Class 1 residential buildings. 2017, Wesbeam started the Tall Timber Building Systems division. They headhunted me out of WoodSolutions to head that up, and the purpose being was because they understood that there is a new opportunity emerging, and LVL wanted to be part of that discussion. Wesbeam wanted to be part of that discussion. Now the true new kid on the block, CLT. CLT, of course, is the term that's been dominating everybody's minds in the space of engineered timber for the last 5 or 6 years in Australia. Similarly with LVL, it was finding a way to use small section timber sections, scantling effectively, from low-grade logs and find a value-added product for it. In the 2000s, we started to see its more widespread use in Europe. First used, I believe, in certainly a large-scale format, 2011 in the Forte building. Is that correct? Is that when that went up? Just down the road. And of course, the signature thing for Australia, I think the thing that really makes a big difference is this year, XLAM established their factory in Wodonga. They're going to be putting out 80,000 plus cubes of CLT every year. From my perspective, whether it be my architect's hat on, whether it be my academic in prefabricated timber, or even with my Wesbeam hat on, I think bringing XLAM into this market is the most fantastic thing, because it has created a domestic supply chain that the market can start to leverage off, in addition to the more established European markets. Okay, so the reason I've got this little pop-up on this slide is that because it's all about finding the right application for each of these materials. CLT is not the answer to everything. LVL is not the answer to everything, and neither is glulam. It's about finding the right application in the right location, and I will extend that even beyond mass timber into steel and concrete. I think we heard some fantastic examples, and certainly from Greg's commentary, about how you can combine steel with the plates into the connections of timber, concrete to make floor panels with timber, concrete working in compression, timber working in tension, the two materials working together. And there's no reason why we can't continue to explore those. So that's mass timber. So we've covered off on innovation, where it goes through to exnovation into the market as a normalised and regularised product, and some of the materials themselves. The other thing that's worthwhile acknowledging is that the NCC now recognises mass timber. This is the current definition for mass timber. It's any timber element greater than 75 millimetres in multiple directions that is formed chemically bonded. It could be CLT, it could be LVL, it could be glue laminated timber. That's the current definition in the NCC. Those of you who are following the development of the NCC in the 1st of May 2019, you'll see that they've actually changed the definition. They've simplified it and broadened it. They've kept the 75 millimetre, and I'll talk about that in a second, but now they've taken away the need to have it chemically bonded. It could be just sawn timber, it could be nail laminated, it could be bracketed, it could be dowel laminated. There's a whole range of different ways that you can hold these mass sections together. And I think this is a really important next step in the process of us understanding what mass timber is. Why is this important in the code? Because the code acknowledges that mass timber brings a particular benefit to a project. Just excuse me for a moment. Specifically dealing with fire. Now, think of it this way. You've all been camping, I'm sure. You've all lit a little fire to put your billy on. Oops, I'll just go back. Didn't mean to jump to that. And you started off with small sticks, and the small sticks burn quite quickly. So you very quickly need to start loading it with bigger sections. The bigger sections sit there and they char away and they allow you to boil your billy. And of course, that takes a long time to burn through. Well, these definitions of mass timber are acknowledging that when you get large sections of timber and they get in a fire situation, they perform differently to small sections. And I won't go into it because that's not what my presentation is now, but that there are a range of concessions that allow you to access in the NCC as part of the deemed to satisfy solutions that recognise that. Okay, so innovation and mass timber products, a little bit more about my journey. Following doing the WoodSolutions workshop with Gregory back in 2007, I decided to begin my own journey, and I started a PhD into prefabricated timber, specifically looking at the innovation and the opportunities that had emerged in Scandinavia. And then I looked at how could we apply those in the Australian context. Well, I didn't want it to be a theoretical PhD, and so I thought, well, how did they start? They started with a couple of guys in a back shed with pieces of timber, and they thought, how can we fix these together? So I developed a nail laminated mass timber panel. It was simply to do an applied application of what I'd been learning in the Australian context. I worked with a couple of Australian carpenters. I worked with West Pine, the softwood sawmill in Western Australia, and developed this nail laminated solution. We had it engineered in a variety of different formats, up to about 5 or 6 story building to take the loads to that structure. So that was something that I thought I needed to do to understand what we might be able to do in our context. This is back in the 2008-2009 period. West Pine very kindly allowed me not only to work on some prototyping, but to build a small design and have a small office building built using this nail laminated technology. Now, this obviously was not a 5 or 6 story building, but it was a proof of concept to say, hey, you can make a mass timber product with a fairly low-tech approach, don't need the big investment, and it can perform according to the specification. So these are some of the images from that project, and I received a Judges Innovation Award. I was a finalist, I should say, as a Judges Innovation Award 2014 Timber Design Awards. All right, stepping on a little bit to my time in Tasmania, the NRAS Inveresk student accommodation building was a building that was developed with you might say early contractor involvement with a number of players in Tasmania to build this 4-storey building. It was on one level of concrete podium with 3 levels of timber on top of that. I used this project as a case study to present it at World Conference on Timber Engineering in 2016 and wrote a paper with Greg's assistance talking about innovation, and one of the key points to take out of that paper was that if innovation is about risk, and it's not only just about real risk but about perceived risk, and if it is determined that perceived risk of innovation is higher than the identifiable benefits at any point in the process, generally it won't go ahead, it will be abandoned. Now, why am I bringing that up? Because I think it's really important to understand the whole pathway of innovation from conception to realisation to application. And there's a whole series of risks involved in that. I'm going to talk a little bit about where my journey is currently in a moment, but in that process, I suppose it's about going into it with your eyes wide open. And if I can draw back into my PhD, one of the things that I learnt from studying the Swedish model was that innovators there in engineered timber products were very quickly and easily drawn away to this latest and greatest thing and this latest and greatest thing. And the determination was that once you've chosen your system, stick with that system, work with that system, limit your options so that you can work that through to finalisation rather than have too many options on the table. These are some of the images of the NRAS building under construction. And there's a couple of key things that allowed innovation, and I'll call it innovation, through that project to be realised into application. One is that there is an incremental process to innovation, and you must accept that, of course. Competitive tendering, and it was interesting that we heard Rob talking about competitive tendering earlier on. There will always be some accessory tolerances. That means that people are starting to add or load their prices a little bit when it's innovative because they're not familiar with it. Speaking to the early contractor ideology again, invite the tendering contractors to come in early on in the process to have input. Construct a full-scale prototype. So that encourages accurate quoting. So for this project, a full-scale prototype of one of the complete student rooms was manufactured, and these are not them, these are the ones under construction actually, but exactly the same as that. And the people tendering it were invited to then come in, look at exactly what it was they were being asked to tender on and price to that, not to a set of drawings, not to try and interpret a set of specification by itself, but literally to take that and apply it to the example that was right in front of them. And then bringing the nominated subcontractors to supply the innovative component. Now, as innovation itself can be incremental, we don't need to innovate the entire project. A lot of innovation went into this project, but not everything. So if you can see there, this is actually a combination of light frame prefabricated volumetric modules and CLT. That image on your right is the CLT, one of the CLT floors, in this case through the connecting spaces between the modules being installed inside a steel frame. So the builder himself was familiar with steel. The design team decided to incorporate the steel and the timber to give some certainty into the contractor. As it turns out, it probably didn't do them any favours because the tolerances of the steel were set to industry standard, which was not particularly high. The tolerances to the CLT, which by the way came from XLAM, at that point New Zealand XLAM, was down to the millimetre, and they quickly found out that the two shall not meet particularly happily. And the feedback at the end of the project from the builder was, well, next time I won't worry about the steel. We didn't actually need it, as it turns out. We could have just done it all in CLT. That would have kept like with like. But that was one of the learnings from that project. All right, so LVL, I'm going to spend 2 seconds talking about LVL itself so you understand what it is. LVL, as I mentioned before, is about peeling veneers off a log. A log is put in a great big lathe and it spins at a great rate of knots with an incredibly sharp knife, which could be 2.4 metres long, and these veneers are peeled off. The veneers themselves are dried and graded so that when the various recipes of LVL are conceived, we know what grades of veneer can go into that recipe, what grades of glue go into that recipe, and they're drawn from that. They apply the glue to the veneer through a skirt of glue which drops down onto the product itself as it moves through a line. Goes through a great big press where it is then pressed up into what we call a billet. It's a big slab of timber. It is continuous. It is endlessly long. At the end of the process, we chop it, otherwise it hits the end of the shed. In our particular production, the billet is 1.2 metres wide, in a range of thicknesses from 35 mil to 75. Come and speak to me later if you want to know more about that. We cut it at 13.2 metres in order to optimise it from a transport perspective. I think we can get to about 17.5. If we cut a hole in the end of the shed, we put a couple of trolleys, it ends up into the ocean and we can float it around the country. But all right, so the billets themselves are made, and that's a massive stack of billets. I think in that case they're 75 mil thick and they're 13.2 metres long. And then you get the end product of LVL. Now from that, you can then make a whole range of things. It can be a planar element as a mass timber floor, wall or roof. It can be as a column, a mass timber column, block laminated to make a large section, or a beam, or you can cut it up into a stud to act as a standard stud and plate or a lintel. All right, so part of my role within Wesbeam is to take the learnings that have been on my journey from Greg and others and start to apply them to a real situation. What you're looking at here is a small exemplar project to talk about some of the uses of using timber in a mass application, in this case LVL. So columns, and you can see by the use of the red and blue how that block lamination might work to make a column out of one of these billet sections. So if the design determines that the column needs to be 600 by 400 millimetres, for example, then you can build up layers of LVL. And because it's being made in this plate format, you can then increase some sections of that build-up to higher lengths than the other and create the opportunity to have a mortise and tenon, if you like, junction, which allows and speaks to how you can start to connect these buildings. So having the elements is one thing, but having the connections is another. You can also make a beam, so you can see the same concept applied to the beam, and that chamfered section is simply a beam that's been cut so that people can actually see the layers. That, of course, would project across and intersect with the column in the real world. You can make a mass floor out of LVL, and this is where you block laminate LVL together, and you can in turn also block laminate other materials. And at the moment I'm working with another company here in Australia to look at block laminating CLT and LVL together to get even a longer span than some of the ones that Greg was talking about. And we're talking 9+ metres in a mass floor at the moment. And of course you can make a mass wall out of LVL as well if you want to. In this instance, it's actually a hybrid mass and light frame wall, which could be used as a dividing wall for acoustic purposes. But this is a part of the journey that we're on at the moment to start help educate the market about what's possible to make LVL, in this case, into mass elements. So, this is the family of elements that I've been developing, if you like, codifying for Wesbeam to share with the industry at large. These elements we don't make, so let's get that out front right now. Wesbeam makes LVL and we bring a lot of smarts to the discussion. These elements are for further up the food chain or up the supply chain, which we like to think that we can partner with and assist with. So, of course, we've got all the standard things that we've been hearing about earlier today. Columns, beams, floors, and walls. All of them can become mass elements. So let's look through some of the column options. In this case, a box. So this is just a snapshot of a document that we will be releasing later on in the year, talking about typical sizes. Now, I believe that there are two areas that the industry at large needs to be aware of. There's the commodification of standardised formats, and then there is the bespoke elements. Now, the fabricating sector in this country, I think, has got a long journey in front of it, but an incredibly bright journey because some amazing examples out of Europe are showing us the way. But it's the fabricating sector that's going to start taking products like these and applying them to buildings. Now, I believe if you take a standardised building, say an office building with a 9x9 grid, typically you're going to have pretty common size, column sizes, pretty common beam sizes. I think every time that somebody wants one of those, they should be able to go to a guidebook or go to the internet, find out who's manufacturing those, what the order of magnitude of cost is, what the performance is going to be, and choose which one of those they're going to select. We shouldn't have to make that from scratch every time. So these are about providing a range of standardised sizes. You can effectively say, I've taken some of the ideas that we worked through on this guide in my early days at UTAS and are now trying to apply them in this situation. Similarly with the mass column, you can block laminate the elements up to make a larger section in a range of sizes and lengths. Now, I'm not saying these are the lengths that typically you could are being manufactured, because Wesbeam's perspective is not about us moving into the prefabrication space. It's about empowering the next sector up in the industry to be able to do this and partnering with them. We're coming up with this sort of term that we're calling the compliance package. And each compliance package is going to be different depending on who you're working with. So these standardised formats I'm talking about here, my role is to work with individual prefabricators and builders, if they're looking to move down the supply chain, to be able to develop a bespoke compliance package according to what their aspirations are, what their market is. So the standardised sizes you see here are just examples. They will vary depending on what people want to make and what market they want to make them for. The same applies from columns straight across into boxes. Those box formats are typical lengths I think the market would be able to use into the mass beam sections as well. You can see a range of sizes on there, which the market may choose to adopt. Floors, you can have a box section, which we call a box, which is being known as a cassette floor, or you can go to a mass section, and each of those are going to have their sweet spots, if you like, about where to apply them. Frames, nothing new here. People have been making frames for a long time now, but I think it's an important conversation to have, because it's not just about mass sections. Mass sections may be used for a particular building application, but frames are going to still be involved because we still need to divide those spaces up. They may be structural, they may not. The design team are going to be part of that, determining what's efficient. And of course, you can have them as mass walls as well. You can actually rotate your billet, your E-slab as we call it, on its edge, and it can take loads straight down the grains in its strongest axis. You saw this picture a little bit earlier on. About a month ago, I was on a WoodSolutions tour to Europe, and I visited this building that we saw the pictures of before. And there we have those, in this case, beach LVL columns and beams, prefabricated, and doing a fantastic job. And in my opinion, they look fantastic. Just out of interest, if anybody recognises that chap touching the wall, that's Tony. Tony's the factory manager at XLAM. So that gives you an idea about where Wesbeam and XLAM are looking to go into the future, where we've got complementary products, not competing products, that can build up what the market itself is likely to need. The 15 story Christoph mentioned earlier on, this is it. This was literally taken 3 or 4 weeks ago. So this here is a concrete building which is going up next to the timber, prefabricated timber concrete hybrid. They both started around the same time. So this gives you a rough order of magnitude about the speed that is being developed in a more established prefabricated timber, mass timber context. So the core was put up, if you look at the building beyond, and they've only got 2 or 3 more levels than that building we topped out. Because they don't need to support the concrete through the curing stage, the lower levels have already been closed, so the timber's being kept dry, and they're beginning the fit out on the lower levels on that. Meanwhile, the concrete building next to it is still stuck waiting for concrete to cure, and there's nothing we can do to speed that process up. This particular project, and you might recognise that chap there, Christoph and Gregory, is actually a graduate of your university. He came over to Tasmania, did, what was it actually he was doing? Something with retropeeling, yep. He is now the project manager for this building, which is being built in Switzerland, and he's demonstrating to me some of the elements that are gone into this project. LVL columns and beams, in this case, beach LVL columns and beams, and that project has got 2 more levels to be completed. But if you have a look, this image here, I'm not really game to press this button. Oh, there we go, I've got it. That there is a plate which connects up on each level, which allows them to make micro adjustments to the height of the building in case there's been any settling or creeping through the process. So they're getting really smart with the way they build these structures, and this is an off-the-shelf product, I believe. So that gives you an idea about some of the possibilities in mass timber. Now, this is my second last slide. This is the slide that tells you about some of the companies that Wesbeam is working with at the moment to go through the innovation process through to EXNOVATION. And if you look across there, you'll see there are representatives across the board. There are builders there are prefabricators there are architects, engineers, developers, and of course other mass timber companies. So this is an ongoing discussion, and it's a broad-based discussion. At the end of the day, we're all in this together, I believe. It's not actually me against you or product against product. It's about finding the correct solution and mapping a pathway with our colleagues. That's my last slide. Thank you very much.